Hi, this mini course is a dedicated series to the IGCP 667 project, World Map of the Origins, sponsored by the UNESCO and International Union of Geosciences. CMGW, the Commission for the Geological Map of the World, is in charge of this project and these mini courses. This short lecture is therefore an introduction to an area in the South China Sea as part of showing the far-field effect of the origins formation to the surrounding area. The example today, I would like to share about how the growth of carbonate reefs reflects the changes of vertical motions in the orogenic formation by showing the example from Luconia province located in the coast of Sarawak, Malaysia. Before we go further, let me introduce in detail where is the Luconia province is located. Luconia is located within the vicinity of the Southeast Asia at the tip of the South China Sea. Luconia block was attached to the China mainland and then it was drifted to the southern margin until it collided with northwest Borneo continents. The collision had closed an old oceanic floor, which is the Proto-South China Sea. At the same time, in the north, there is opening of present-day South China Sea. This area, Luconia province, is dominated by oil and gas exploration, particularly explored within the carbonate reservoir. So we are going to focus and see on how the carbonate reefs actually show the records of vertical motions. Before we go further, let's see what is the geodynamic setting of Luconia block. The Luconia blocks went through the extension of the South China block from 60 to 32 million years ago. This is where the rifting of the South China block, which includes Luconia, Dangerous Grounds, and the surrounding area. It was then drifted to the southern part. During 32 to 16 million years ago, this block went through seafloor spreading, followed by convergence in the West Borneo wedge and uplift and compression in the Northwest Borneo. This happened after the seafloor spreading. During 16 million years ago, it is confirmed that the old oceanic floor, which is the Proto-South China Sea, has fully closed and Luconia block subducted. Part of Luconia block subducted or collided with the Borneo continental shelf. So there is collision between continent of Luconia and continent of Northwest Borneo. So due to the collision, we have uplift topography. So the collision has great origin. A cross-section from tip of the South China Sea to onshore Sarawak shows Luconia block receive echo of deformation from the extension in the northwest and compression in the southeast. This creates a vertical motion on Luconia block and it is translated by development of structural lows and high. The structural highs become the host for prolonged growth of carbonate rocks in Luconia. Luconia then developed as a foreland basin after the docking of continental block with the Northwest Borneo mainland, and this induced uplift in the south and onshore. So again, it provides structural highs for some of the earliest limestone to grow. As the basin grows, sediments input from the hinterland area, from the orogenic build-ups, are then transported to the basin, including Luconia in the offshore, and these create gravitational sagging and compression in the basin. um, where most of the limestone die because of high clastic sediments transported to the block. Before we go and see the evidence of limestone growth in this area, let me share with you that the growth of carbonate in Luconia and its surroundings are highly dependent on structural setting of the basement and the blocks underlying the limestone. They are two major structures that is responsible, which is the compressive structures, creates higher topography such as anticlines over here, and this anticline become the host for the carbonate reef to grow, particularly within the axis of the anticline. And if the environment is permissible, the limestones will start to grow at the limb of the structure. While extensional setting in the central and northern side of Luconia province created tilted faulted blocks. As example, the horse and graben over here. At the tip of the tilted blocks is usually the highest point, and this is where we can usually see pinnacle-shaped carbonate build-ups. The reefs in Luconia are mainly dominated or found within middle to upper Miocene. This is for the exploration part. So the details descriptions are mainly for middle to upper Miocene limestone. However, the evidence from seismic and well shows that they are much older limestone deposited deep in the subsurface of Luconia. There are two types of carbonate growth in Luconia. The first one is mainly in a flat, elongated carbonate platforms, as example over here, while the second one we have a conical shape carbonate build-ups, and this is usually a smaller in size compared to the flat top carbonate platform. The limestones build-ups are concentrated within the central section or central Luconia over here, while in the northern section the reefs are still growing present day. Based on this map, we can still see this blue zone where this is the present day carbonate reef, and this is also near to dangerous ground. So Luconia, dangerous ground, and Luconia are a continental block that was drifted from South China block. Now let's have a closer look on how the reefs grow in Luconia in response to the structural patterns preserved. We will start with the A to A prime, showing cross-section from the offshore to the onshore sections. So in the onshore section and in the offshore sections, in the near shore sections, we can see folds, similar fold patterns. The folds are low angle folds and having long wavelength. From the seismic data and the well data, it is proven that they are upper Eocene to lower Oligocene limestone growth from onshore to the nearshore sections. These two wells are showing this evidence. The reefs are dominating the axis of the folded strata, and they are also grow laterally towards the limb of the folds. However, they are just in patches, they are not continuous, and they did not connected into each other. Let's see an examples from fields showing Eocene to lower Miocene limestones outcrops that's distributed sparsely on the onshore of Sarawak. This is the line of our seismic sections that we just see in previous slides with Engkabang limestones over here. A famous Eocene limestone outcrop is located in Gunung Mulu National Park. This is example of Mount Mulu, Eocene limestone. And then we have Eocene to Oligocene limestone located in Batu Gading area or nearby Long Lama. This is a quarry where the boundary between Eocene and Oligocene limestone can be clearly seen. Lastly is the area of Subis or Batu Nia. This is where we have Nia Cave. So the upper picture is showing the morphology of the cave, similar to flat top elongated platform that we see in the previous slides. While the bottom picture is showing Setap Shale formation with remarkable limestone patches. So these limestone patches are highlighted in this black dashed line, and they are continuous within the Setap Shale formation. A clear example of compressive structure can also be seen in Batu Gading area. This is an intensely folded and fractured limestone float within an even more intensively folded and tectonized mass shales and slates. So all the photos here are courtesy of Kessler and Jong 2016. Another example of seismic is from our regional line, which is oriented from south to north of Luconia and in northwest-southeast direction. It is showing how the structure, crust, and sediment thickness varies in response to different tectonic phases it has experienced in a long time since Cretaceous to present day. This regional line shows a consistently thick limestone growth and on a uniform and thick crust overlying by clastic sediments in the southern to the central section of Luconia. So they are mainly in elongated platform and some of them grow in pinnacle shape. While as we can see, the area in the southeast to the central of the line is minimally impacted by faults, except for a few normal faults and reverse faults within the carbonate build-ups and the clastic underlying them. Meanwhile, in the deep water section, in the northern area, it shows limestones grows on structural lows and high. Thicker limestones build-ups are found in the high tip of the horse blocks, while thinner limestones are found in the lower or in the graben. Structurally, the northern area is highly impacted by normal faults. Some of them are very large-scale list-strip faults and can be seen up to the lower crust, showing the effects of the extension in the north. A clearer example of how carbonate reef are controlled by vertical motions of the orogenic build-ups can be seen in the Palawan, north of Luconia, where it is nearer to the subduction and collision zone. So in Luconia, it is like at the southern of Palawan. So Palawan is over here. Palawan is in the north and Luconia is located over here. So the subduction or the closure of Proto-South China Sea and subductions of continental blocks underneath Palawan is more obvious. So we can see that the blocks are coming in down underneath Palawan. Over here, the growth of reefs associated with the opening of the basin at the top of a tilted blocks, as we can see in the Oligocene over here. Then these reefs were uplifted with the flexure compression or that creates the domes of this doming, and then eventually allow subsidence in the basin. It was followed by middle to late Miocene reef, and some parts of the areas continuously grows. So in Palawan, the growth of limestones are continuous and connected to each other, while in Luconia there are patches of the growth from Eocene to Oligocene, and it only become continuous in Miocene because of the location is further from the collision and subduction zones. So from here, we have developed a model. So during the first event, which is the closure of the southern part of the Proto-South China Sea or the drifting of the Luconia continental block, it has triggered extensional tectonic from the active rifting. And this has actually developed elevated topography in the southern part of Luconia blocks, where it provide house or provide template for the Eocene to Oligocene carbonate growth. So because of we have compression in the southern part of Luconia block, it allows growth of reef. It was then followed by extension in the north of Luconia block. So we can see over here during 16 to 32 million years, in the northern section there were still active extension. So no growth of carbonate are recorded during this time. However, there are Eocene and Oligocene limestones recorded in the southern towards the onshore section, as what we see in Engkabang and in Tinja province in one of the seismic section just now. And then when the growth continuous in the southern part in patches, they are not connected because the tectonic was still continuously active at this time. But after middle Miocene, the limestone starts to grow because tectonic stops. There's no activity. And finally, the present day, we have sediments, classic sediments covering all the carbonate build-ups, and they die. So reefs are good indicator in this area to show that this area was sustained at shallow level for a period from Oligocene to Upper Miocene, and it underwent uplift from the topography in the subsurface during Eocene, thus allowing patches of reef to grow on elevated structures. So before I end my presentation, some take-home message are the orogenic building in Sarawak begins during Eocene. It created compressive structures such as anticline, where suitable location limestones can grow on this axis of the anticline. This is one of the example. So there's fold and we can see continuous limestones. The dark blue color is the limestones. Luconia blocks receive the load and the bulge from the mountain building in Borneo. And this include the consequence of slab break-off at the end of the orogenic build-up. So at the same time, during late Miocene, or the growth of riffle build-ups in Luconia contracts into pinnacle shapes, and where this is seismic line showing both the flat top carbonate platforms and the pinnacle shapes. But this is evidence of reefs keeping up to grow, because by this time sediments, classic sediments starts to being transported to the basins. So the riffle build-ups in the south, usually this is the eastern, southeastern part, is already begins to diminish. So we can see that in this single seismic line, there is less limestone build-up towards the southern east, while more limestone build-up towards the northwest and central section, because they die earlier due to the gravitational tectonic and transported of clastic sediments. So here are the resources for our project. And before I end my presentation, I would like to acknowledge Malaysian Petroleum Management of Petronas for providing the data for this research, and this study is part of collaborative between UTP and Economal Superior. With that, I thank you.